I think not working. I'm sorry. So can ah? Yeah. Sorry, sorry. Good afternoon. I think now you can mark attendance. Okay.
Wait.
Don't worry. Text me. Text me. Don't worry. Text me. Text. You text me. I can update it manually. Yeah.
Okay.
Okay. Don't worry. So now we see the next group, PT20. Yeah. I mean, if only one or two students, easy. Yeah, but let's say many, you better do it. Self service. Okay, self service. Okay. Okay. Now for PT20, you can mark attendance. Yeah. Okay. Okay. Now for ODL, you can mark attendance. Okay. So anyone not yet mark attendance, you can text me, yeah, and mark attendance for you now. Yeah. So just text me in the chat box. Yeah.
Yes, sir.
Wait, yeah.
Yeah. Ân Thiên Viết ODL.
Okay. Okay. Wong Hong Check, I think you already marked attendance. You supposed belong to this group, correct? Okay. No, not here. You are not here. How come? Okay, we check one more. Maybe you are here. Yes, correct. Done already. Yeah. Okay. So now what we okay. So now we see the planning for the quiz. Okay, the quiz. I mean, as I mentioned in the beginning of the semester, so we should do the quiz one first. Okay. So quiz one. Okay, then we see the schedule. So we see the schedule. The quiz one will cover two topics. Okay, two or three. Two. Okay. So means now today we must finish the logistic and then discuss discriminant, and then we start the logistic soon. Okay. So means almost we are you are supposed ready for the quiz one. Okay. So just for your info, maybe next weekday class, but we see how. Okay, we see how first. Yeah. Okay. So we see. Okay. And then now we are still in the logistic. Sorry, we are still in the factor analysis. Okay. We are still in the factor analysis. Any question you want to ask? Yeah. So for the previous discussion. Okay. Okay. If no, now we are here. So this part actually we discussed already. So basically, common means refer to the common factor analysis. Therefore, it's more to the data. Okay, data reduction. Yeah. Okay. So okay, means what we do, we should actually select the interpret the factor. Okay, not on the select the method. Yeah, but you must interpret the factor. Of course, a different method you should interpret differently. Okay, so but different also not too much. Okay, different also not too much. Yeah, so we just mention the important factor. Okay, they group together means they have a similar feature. Okay. So, so determine the number of factor to represent the data. Okay. So discuss also already the strategy. Let's say you get 4 factors based on the eigenvalue. Okay. Based on eigenvalue, you get 4 factors. Then you can have you can run again. Yeah, you fix it at 3 factors and also 5 factors. Then we compare the result. Okay, like that. Okay. Okay. So you see, next, yeah. So let's say, okay, how to make some comparison? Example, let's say, 4 factors, yeah, 4 factors and 3 factor, 5 factor. The statistics result different not much. It means either one is okay. Okay, it means it's quite stable. Can be 4, can be 3, can be 5. Okay, but sometimes maybe the 4 factor result good, 3 and 5 not too good. Okay, so that's why we see some testing. Okay, so we see next. Yeah, so we still here. interpreting a vector matrix. Okay. Wait, yeah. Okay. So we examine the vector matrix of the loading. Remember, this is the relationship between the variable with the vector. Okay, the vector matrix. Okay. So, therefore, from there you can do grouping. Okay, we can do grouping to find how many vectors you have. Okay. Identify the highest loading across all vector, yeah, for each variable. Okay, so this also discussed already. In case you cannot find it, let's say got cross loading. Okay, yeah. Let's say this one happen. Yeah, means what? Means the what they call the loading is quite high. Yeah, for both vectors. Okay, let's at this Okay. The factor 1, factor 2, but for this variable it's quite high, 0.89 and then 0.91. Both quite high and also quite close. Therefore, we do know this variable should belong to each one, each factor. Therefore, we do rotation. Okay, yeah. Okay, so, and then make sure you still remember this thing, the commonality. I think discussed already, is it? Anyone? Must be more than 0.6. I think already done, yeah. Okay, if not, you let me know. Yeah. Yeah, done already, yeah. Okay. So the value must be more than 0. Wait. Okay. Okay. For the quiz and test must be all written, and then some will be concept theory, some will be the interpret the output. Okay, you can see the sample test, sample quiz. Okay, so this one you have this also in your Moodle, your sample in course. So example sample quiz 1. Okay, sample quiz 1 concept. Yeah. Okay, concept, but can be also some output and then you interpret the result like that. Okay. So this quiz 1, therefore only 20 marks and then will convert to 10%. Okay, quiz 1. Okay. So you see sample quiz 2 also similar. Yes, some concept. Okay, but I actually also ask some case, means you must know how to apply. You understand the idea and then you know how to apply in different contexts. Okay. And also the test okay, the test. Simple test. Yeah, simple assignment not much meaningful. You have the assignment already. Okay, you have the actual assignment already. You see simple test. Yeah. Okay. Okay. Yeah, this one like this means us give some output. You do some discussion. Yeah. Okay. So this is yeah, this test this test. Yeah. So but the quiz also may have some output. Do some discussion maybe. Okay. Okay. Okay, if no question, now we continue. Yeah. So we are here. So therefore, commonality actually must be more than 0.6. You only consider the variable is valid. Okay. So of course, again, this is just a guideline, not too strict. Yeah, let's say 0.58, we still can accept. Yeah, but the higher is the better. Okay, the higher is the better. Let's say too small. Yeah, let's say 0.2, you better remove. But should be high or quite close to 0.6, because we already filter it in the MSA. Now it may consider like second time you do the filtering. Okay, but the different method. Okay. Okay, so this is the commonality. Means they contribute about 60% to the factors. Let's say got three factors. This variable consists of 0.72. Therefore, this variable contribute 72% to the three factors. Like that, okay. So that's the interpret. This what means that's what we can do based on the output. Okay. So and then label the factor. After rotation, you should be able to get the factors. Yeah, then you label it. You give a name. Okay, give a name. Yeah, to a more general name to reflect the variables. Okay, this one also discussed already. Means first method you try to consider a term that cover all the variables in that factor. In case not, you cover maybe half or three or two variables also good. Worst comes to worst, you will use only one, the name of the variable. Okay, the name of the variable that have the highest loading. Okay, this interpreting factor matrix. Yeah. So, okay. Okay, good question. Okay, you no need to use the software. You only write. Yeah, write is better. Write is better than type because sometimes you need to do some formula, use some formula. Sometimes, yeah. Okay. So, but actually mix also can. Yeah, means sometimes type, sometimes you write also can. Okay. I mean, you write and then you take photo. Okay, this will give you 30 minutes. You have to do the to take photo and upload the answer to the Microsoft Word, and then upload. I mean, copy the photo to the Word and then upload to the Moodle. Okay, okay, and then yeah, you no need to use the software. Okay, yeah. So continue. Okay, so okay. So now we interpreting the factor. An optimum structure exists when all variables have high loading, only on a single factor. Can I see? Okay. So, but let's say different a bit means are not too good, like this case. Okay. For 89.91, different too close, different, not much different. Yeah. Okay. But say different a lot, then it's okay. Example 0.8 and 0.6. So we take this one. Okay. Okay. So, okay. Variable that cross loading, yeah, meaning that they load highly on two or more factors, like this case. Okay, it's cross loading. Okay, so are usually related, yeah. Uh, you can also follow this, no problem. But normally, delete the variable is the last option normally. Okay, so but anyhow you can follow also, yeah, no problem, yeah. So unless theoretically justified, okay, this is what I mentioned. You uh, delete delete the variable should be the last option because why you consider the variable? Because you already justify it in your chapter 2. Okay. So of course, you may delete it in case data is from another party. Yeah, data from let's say from a company, they give you the project. Yeah, therefore, you may actually also remove it. You can give some reason. Okay. So, okay. Okay. So now we see variables should generally have community. Okay, 0.5. Okay. Again, some textbooks say 0.6, some say 0.5. Therefore, in the same slide, you may find some part they say 0.6, some say 0.5. Actually, it's not very, it's not a golden rule. Okay, that we must use 0.5 or 0.6. Okay, statistics is not mathematics. Okay, I think I mentioned this before. Okay, in another class, not in your class. Okay, let's say 6 plus 3 confirm must be 9. If you look for 1 million textbook, everybody say 9, but this one is different. A different textbook can give you different value. Okay, because they use different method. Okay, to prove it, and also due to the sampling error. Okay. Okay.
So, sir, how are you going to give marks if some put 0.5 and 0.6 in the quiz, let's say?
Okay. So therefore, okay, good question. So here got two issue. Okay, first thing is for let's say for the exam or test. Yeah. So, normally the question that we ask will be different a lot. Means it's easy for you to what they call easy for you to justify. Yeah, which one should be removed, which one should be included. Okay, so it means I'm not going to give you 0.55, make your life difficult. Okay, but in general, more than 0.5 is okay lah, still okay. Yeah. Okay. Second issue for the capstone. Capstone, not much problem. You must do some citation. Okay. Example, let's say your study is more on the finance, then you should find some article that they do the similar study also in the finance. See what value they use. They use 0.5, then you follow 0.5. Because it's similar study, can I say? Yeah. So finance maybe cannot apply in the manufacturing, it can be different. Okay, because different sector. Okay, so if no problem, now we see. Yeah. So this one may happen also means you may read specification of a factor analysis. Means you may actually remove a variable. You may also change the rotation method. For example, the first rotation method, you cannot remove the what do you call the cross loading. Yeah, you can change a new one. Yeah, then see how's the result. Okay, so you can also increase or decreasing the number of factor. As I mentioned just now, let's say the software give you 4, you may test 3. Let's see how. Yeah, maybe result better. Yeah, okay. So maybe 5, maybe 5 like that. Okay. Result better means not many cross loading, and you can easily identify. You can easily do the grouping. Yeah, to see the variable belongs to each group like that. Okay. Yeah. So this is the interpreting the. Okay. Yeah. So I think for the break time, we still follow the schedule. Means the first break will be 3 o'clock, 3 to 3:30, and then 5 to 5:30. Yeah, we just follow. Okay. So okay, any question for this part? Okay. Yes, ask now. Yeah.
So sir, just to get the ultimate guideline. So for factor analysis to have the best result, it means we should have a very clear factoring and no ambiguity, no cross-loading, even though we deleted some of the variables. So that's the ultimate goal we want.
Yes, correct. Okay. Okay. So means this is the extreme case. This is really, really bad. Yeah, it means they are very close. You cannot say, of course, we know 0.91 is higher than 0.89, but different not much. Okay, but if 0.8, 0.6, oh, okay, 0.6, 0.8 is better than, is higher than 0.6, like that. Okay. Okay, of course, you also must meet the assumption, okay, before you start the factor analysis. Okay, so yeah, it's important for you because your assignment, yeah, because this topic is important because more than 20%, kan? Your assignment 40%, yeah, chapter question number 2 already 20, yeah, about 20%. Okay. Okay, I think question 2 about 40 marks. Therefore, about 20%. Also, other quiz also ask it again. Yeah, the factor analysis. Therefore, it's very important. Okay. Now we see. Wait. Okay. Okay. Keep saying if you're talking about the quiz test, yes lah. Yeah, same question. Yeah, this yeah, cannot be different. It cannot be different. Okay, unless it's some professional exam, but for uni exam, same question. Okay. IOC Siong, I don't think we have. Yeah, so we can only do rotation. Okay, we can only do rotation. Yeah, there. Okay, okay. Of course, another method is that you can, when you design the questionnaire, you try to make it clear. Yeah, let's say, okay, okay. If you're talking about the method of data analysis, we don't have, but you can try to make it really clear in your questionnaire. Okay, so example, let's say you have 30 questions, you're targeting 6 factors, yeah, and then 5 question, yeah, for each factor. Okay, so when you prepare the question, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These first 5 should be used to represent the factor 1. Yeah, okay. This one should be used to represent factor 2. Okay. Means the process you go through clearly and then carefully. Therefore, the question that you ask actually will be used to represent factor 1 only. Okay. Okay. Let's say, these 5 questions will be used to present factor 2 only. Let's say you find some question looks like not very clear, can be used for factor 1 or factor 2. Therefore, you better remove at the beginning. So you only means question 1 is very clear, is to represent 1. Okay. So example, financial situation. Yeah, own a car or not, own a house or not, cash, anything. Yeah, let's say some investment in mutual fund. Therefore, all about finance. The financial status of a person. Can you see? Okay. But 2 is a different thing. Okay, that's the first method. Okay. So means if the question, if you are the one who prepare the questionnaire to get data, you can control all these things. So second thing, you can control, you can filter the respondent carefully. Okay. Let's say you're targeting working adult. Okay, working adult. Therefore, let's say some full-time student, yeah, no work, means it should not be your respondent. Like that. Otherwise, the result may not be good. You find really, really someone who actually meet your criteria, yeah, as your respondent. Like that. Okay. So that's what we can do. Okay. Okay. So if no more question, now we continue. Yeah. Okay. This one done. This one also done. Yeah. So we see validation of the filter analysis. Yeah. Yeah. Okay. So confirmatory perspective. Okay. So another method. This one is to what they call, to make your result more convincing. Okay. So validation. Okay. So actually first method also discussed already. Okay. You can separate the sample. Okay. Let's say in your first testing you use 10,000. Yeah. Okay. And then you find that variable 1, 4, and 5 can be grouped together, yeah, as factor 1. Okay. And then variable 2, 3, 6, 7 can be grouped as factor 2. Okay. Now you can separate the sample like this, yeah, N1, N2. Now let's say 5,500 and then 4,500. The sample size. You separate the two, you do testing. Let's say you get the same result. Yeah. 1, 4, 5 also representing factor 1. Yeah. And then 2, 3, 6, 7, 4 variables representing, they can group together, group for factor 2. So means the result is is very good. Okay. This is the how we can do. Okay. So this one you get it, you separate it randomly. Okay, this is the first one. Okay. So okay, if no question, now we see second. So second is that you can still separate the sample, but based on few category. So example, maybe the first one is they study up to high school. Yeah. Up to high school. Second is the pre-U until U. Third is the postgraduate until and also professional. Okay. So you got 3 groups. The first group, let's say 3,000. 3,000. Here is 4,000. Again, you do the same process. You got 3 sample. But do the grouping based on the category. So either one is okay. You can use. Okay. Okay, so this is a complementary perspective. Okay. Okay, if no question, now we see next. So second is assess the factor structural stability. So this one is the more to the number, the sample size. Yeah. So the case of the case over the variable should be high. So higher is better. Okay. Okay. So case means you refer to the number of observation. Example 10,000 like that. Okay, case is n. Okay, n. So number of variable that you have. Yeah. So the ratio is higher means it's better, means more stable. Okay, the vector structure is more stable. Okay. Okay, so the third one is the deleting the inferential observation. This one discussed already, is it? In the multiple linear regression. You can refer to that chapter. Okay, so means you can also do this before you run the vector analysis. Okay, yeah. Okay.
So sorry, sir. Confirmatory perspective, can I say it's similar to bootstrapping?
Similar to?
Bootstrapping.
Oh, okay. Something like that. It's a different term, but it's quite similar thing. Okay. In some area they call it robust. Yeah. Yeah. Good point. Yeah. So yeah. Okay. Okay. This one, some they call it robustness. Okay, robustness check. Okay, something like that. Okay, so it's quite similar idea. Okay, so but this one is more. They can do it for random. Right? They can do random means they can do it. They will take the sample. Can be also repeating. Yeah. Example, you have 4,500. No, 10,000. Yeah. But under this method, they may get a sample of 100,000. Can I say means what? In some observation they will be repeating some. Okay. So sometimes robustness check they use different method. I mean similar method but a bit different. They do testing, they see the result. Result still good means it's stable. It's robust means it's more convincing. Okay. Yeah. So but there's something that they cannot do. Example, they cannot separate to three groups, correct? Category of the different level of education. Okay, you make it three groups, you do testing, but this one they cannot do using the bootstrapping. Yeah. Okay.
Thank you, sir. Got it.
Okay. So okay. So if no question, now we'll continue. So now, okay, Santana. Okay. Now we see additional use of the filter analysis result. Okay, so we selecting this one surrogate variable. Yeah, so actually it's the only one variable. Means what? Means you can also use this. Yeah, and then for use the result, and then use it for other data analysis. Example. Yeah, let's say this one means what? Means you the factor one, under factor one, you got, you got three factors under the factor one. Let's say the variable one, variable two, and variable five. So choose only one variable with the highest loading. Let's say variable two. Then you use this one to represent the factor one. Okay, and then means you ignore variable one and variable five. Okay. And then you use this one, as the available and you use it in the testing of the multiple linear regression. Okay, now it's an anchor, it's like the something like that. Yeah, the highest loading only use one. Okay. Okay. Any question? Yes. Okay. So means based on the result, you get the highest loading. Okay, then if I use it as an independent variable in the multiple linear regression. Okay, this is the first application of the result of the filter analysis. So second thing is creating summated skill. Okay, let's say you got three. I think this one discussed a bit. Yeah. Let's say you got three, you can use the function v1 plus v2 plus v5. You get a value, let's say x2. So this one will be the independent variable. Yeah, in maybe in multiple linear regression or in your structural equation modeling. Okay, so submitted. Okay, Of course, you can be a little bit more creative. Example, you think that the variable 2 highest loading, you give some weightage, let's say 3. Can I say 3 times V2 like that? Of course, you must justify. You must justify in the project or in your capstone like that. Okay, so the third method is computing the factor score. This one the software will do for us. Yeah. Do you still remember how to do the? Okay, not. Okay, a quick one. We do it. How to do the factor score? Yeah. Now. Yeah. So, factor analysis. Yeah. So dimension reduction. Factor. Okay. So we don't want. Remember, we don't want 3 variables. Okay. I recorded it. Yeah. Okay. So now we want everything. Yeah, correct. Here, not dependent. Yeah, all independent. Yeah, but we don't want. Okay, we don't want 6. Okay, we don't want. I mean, we want every all the metric. Okay, all the metric variable. Okay, we don't want 6. We don't want 13. We don't want 16. Okay. So now I show you how to get the factor score now. Okay. So, okay, it's okay. Not just simply do. Yeah. Okay, the important thing I show you how to get the. Okay. Yeah. Okay, correct. Can you see score? You save it. Save as variable. Okay. Okay. So and then continue. Okay. So you get 4 factors means 4 columns here. Okay. So they still do the factor analysis, but then they will create 4 columns for us. So they representing the factor score for each factor. So for factor 1, factor 2, can you see here 2, 3, 4. Okay. So this is the factor score. Okay. Okay. Any question? Yes. Okay. So if no, now we see.
So sorry,
Yeah, ask now. No, sorry. Ask. Okay.
what's the how we use this factor scores?
Okay. Okay. Good question. Means what? Um, how to use factor score? Okay. Let's say you got 4 factors already. Okay. 1, 2, 3, 4. Okay. So here you can put a name. Let's say F1, yeah, F2, F3, F4, and then you can let's say in the same data you have also the dependent variable. Therefore, you apply it, you run the multiple linear regression. Yeah, dependent variable, you have the independent variable 1, independent variable 2, independent variable 3, independent variable 4, like that. You can do multiple linear regression. Okay? Yeah, like that. Okay. So we see also why. Why do like this? Can we actually just use all the variable here? All the variable here, we do the multiple linear regression. Yeah, maybe can, maybe cannot. Yeah, sometimes cannot because we don't want. Remember parsimony. We don't want too many independent variables. Okay. Let's say. Okay. Let's say the n over independent variables is too small. It's not good. Can I see? Example 100 over 20, you get only 5. It's too small. Yeah, 100 observation, 20 independent variables. It's not good. Okay, so therefore we can reduce independent variables to 4. 100 over 4, you get 20. Therefore, it's better. Remember, you estimate too many coefficients, you lost degree of freedom. Okay, means the result may not be good. If you estimate too many coefficients, too many parameters, too many coefficients. Okay.
Oh, sorry. So because in the factor scores on the columns, every variable got this the factors got its own scoring, so just not sure how to interpret the scoring.
Yeah. You're right. You're right. You're right. This is a problem. This is a problem that we're going to discuss a bit in the shower. Okay. So it's a
Okay.
disadvantage, yeah, of the factor analysis. Therefore, we can only use one thing. Instead, we use the one with the highest loading. Okay. This is one option. Okay. Yeah. You are right. It's one of the disadvantage, yeah, of this method. Okay. You are right. Okay. Okay. So we continue. Yeah. So we see a bit more submitted method is only as good as the item used to represent the construct. Okay. Remember just now? Yeah, this method. Okay, submitted. Okay. Okay. We may pass all empirical tests, but it's useless without theoretical justification. Okay. So means still okay, it can be used. Yeah. Okay. So this one okay, but of course we do testing first. Yeah, we do factor analysis first. They only create the submitted skill. Okay. Okay, so we can use this one is no problem. I can show you also the reliability analysis. Okay. Okay. So should more than 0.7. Okay, I'll show you how to do this now. No problem. Yeah. Okay. So anyone can remember? Okay, sorry. Okay. I think we have this. No. Okay, I just simply use this output. Okay. Okay. So example, let's say number one. The factor number one. So we see I write down. I use a pen. Wait. Okay. So we see the factor one. We find the highest loading. Yeah. Therefore, we can include x7. I mean factor one. Factor one you can consider x7. Okay. Wait. Not here. Eh? Oh, okay. Because I did not click the rotation. It's okay. We do again. Yeah. Okay. Okay. So, okay. It's okay. We try a different one. Yeah. Okay. So now we use the structure component matrix. Structure matrix. Yeah. Okay. Rotated. Okay. Rotated. Okay. Okay. So this one is also it's similar if it's rotated, but of course it's because you use different method. Okay, for different name they use. Okay. So now we see factor one. Factor one. Okay, we can consider x9. Okay, and then okay. Okay, and then 17, 18, 19. Okay, so 17, 18, and also 19. Okay. So now we see the reliability. Yeah. So reliability.
Hi, sir.
Yes, ask now.
Yeah, I think we should exclude the variable 15, not 16.
Wait. We should.
We should exclude 15, if I'm not wrong.
15. Wait, yeah. Oh, okay. Yeah, thank you. You're right. Yeah, thank you. Okay, I do again. No problem. Yeah, thank you. Yeah. So we do dimension, factor. So okay. So we should 6, 13, 15. 6, 13, 15. Okay, so we want 16. Yeah, thank you. You're right. Thank you. So 6, 13, 15. Yeah, thank you. Okay. So now we see the result. Yeah. So now we are here. Okay. The last, yeah, correct. This one. So we take. Okay. Okay, so we take x7. Okay. X9. Okay. And then x14 means you see the factor 1, factor 1. So x14 and then x16. Okay. Any question? Yes. Okay. So if no, now we see the reliability analysis. Okay. Now yeah. Okay. So okay. Analyze and then wait. Okay, skill. Okay, skill and then reliability analysis. Okay. So now these four supports that can be used, to represent the one factor. Okay, factor 1. Yeah. So we see the internal consistency. Yeah. Okay. So should be high. Yeah. More than 0.7 means good. Minimum 0, maximum 1. Okay. So we want x9. Okay. X9 7. 14. 14. 16. Okay. 9, 7, 14, 16. Yes, correct. Okay. So Chromebook Alpha is the most popular. Okay. Most popular doesn't mean the best. Okay. But we just follow. Okay. So if you want to use a different one, you must have some support, from textbook or article. Okay. We see Alpha only now. Okay. Okay. You see the basic only. Yeah. So this is the result. It's quite good. Wow, it's really good. Okay. Okay. So 0.856 is more than 0.7, therefore it's good. Item means 4 variables. We included 4 variables. Okay. So this is the reliability analysis. Yeah. Okay. Okay. We use reliability analysis if the data is come from the questionnaire. Okay. So you want to see the internal consistency. Okay. The term that we use is to examine the internal consistency. Okay. So or to see the questionnaire reliable or not reliable. Okay. So can you see again? Got two different values. Yeah. So for us, of course, 0.856 is much more than 0.7. Therefore, it's considered good. Okay. 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 So the threshold should be rise, as the number of items increase. Okay. So let's say you got more, you include more questions. Yeah. Therefore, the threshold should increase. Let's say 0.75 like that. So depends on the study. Okay, in the article. Okay. Okay. So okay. If no question, wait. Actually, in the filter analysis, the variable must be metric. Yeah, not because of the filter score. Yeah, but the variable must be matrix under the filter analysis. Okay. Okay. Yeah. So you can also see the requirement of the assignment. Yeah, filter analysis, the score, the variable that you use must be matrix. Okay. For n divided by independent, what is the minimum we should maintain? Yeah. Okay. So as usual, more is better. Yeah. So it also depends on the actually I think there's guideline mentioned in the beginning in the slide. Okay. So divided by the independent. Wait. Oh, okay. Okay. I think which one you're referring to? Yes, correct. You're referring to this one. Okay. So if you see this one, you can follow the guideline of the multiple linear regression. Yeah, 5 is really minimum. If 10 is 10 or above is better. Okay, 10 or above. Okay, minimum 10 lah. Okay. So again different textbook they may say different thing. Okay. But in general 10 or above lah. 10 or above is considered good. Okay. Okay. Okay.
So the formula here actually is called parsimony ratio, is it?
You mean this formula?
Yeah.
No. I'm not sure the term, but this we use in the in statistics. Yeah. So okay. Yeah. So the case over is for us to test the factor structure stability. Okay. So I don't think we have a special term for this, but it's a ratio. Okay, it's a ratio for the case to the number of independent variable. Okay. Now we are here. Yeah. Okay. Okay. We see. Yeah. Okay. So now we see the reliability established. Therefore, validity should be assessed in terms of these three things. Okay. Conversion, validity, skill correlate with other like skills. Okay. So, okay, means what you do, you can find a different data set. Yeah. So each actually measure the same concept. Yeah. Okay. You see this one, So you can find some another data set, but they measure the same concept. Yeah. Okay. Then you do some the calculation to see the correlation. Okay. So compare the correlation, make sure it's high. Okay. If high means good. Okay. Yeah. Okay. So.
So sir, this reliability is only used when we want to do these submitted skills, right?
Yes, correct.
The unidimensional is to make sure is that their unit dimension is the same or
No. Means the skill is only measure one dimension. Can I see? Means even you sum four variables. Yeah, three. Let's say three. But this one only representing one dimension, but not two. Okay. Yeah.
okay.
Okay. So if no question, now we see next. Okay. So next is it's the opposite. Discriminant validity skill is sufficiently different from other related skills. Okay. So they are similar concept, but actually they are different. Okay, example. Yeah. So example, the purchase. Okay, purchase intention and also the satisfaction level. So these two looks like quite similar, but actually we know they are different things. Okay, so purchase intention doesn't mean satisfaction. Okay, but let's say these two, you run the correlation, yeah, the correlation is quite low. Means it's good lah. Okay, means they suppose no relationship. Yeah. Okay, means let's say the submitted skill you get, the variable that you get is the purchase intention. Based on these three variables, your X2 is the purchase intention. Okay. Then you do some correlation with the satisfaction of the customer. Yeah. Then finally you get low correlation. Means it's good. Means purchase intention is not satisfaction. You got no correlation. Okay. Therefore correlation low means it's good. Okay. Yeah. Okay. Any question? Yes. Okay, these two variables should be similar, but actually different. Okay, this may be the term that we use in the statistics, also mathematics. Okay, they are similar, but not the same. Same means what? Means 5 equals to 3 plus 2. They're the same. It equals. Okay, similar means not same. Similar. Example, 9 is similar with 8.2. Quite close, similar. not the same. Okay, like that, something like that. Okay, so means these two concepts looks like quite similar, but they are different thing. Okay, yeah. So, okay, this is a second method for us to do the validity. Okay. Okay. If wait. Okay, see any question from online student? Yeah. Okay. Okay, done lah. Okay. So if now we see next. Okay. Nomological validity. Also skill predicts is theoretical suggested. Okay. So the skill is quite similar with the theory. Therefore, it's a good. Okay. So example, when you run, once you've done this, yeah, this is your independent variable. You're in the multiple linear regression, and the coefficient is consistent with the theory. Therefore, it's a good example. Yeah. Wait. Okay. Okay. Let's say purchase intention. It's okay. I use a different. Okay. Let's say your purchase intention is the independent variable, and then your dependent actually is the, let's say, royalty. Okay. So royalty to the swimming complex. Okay. So let's say this is a theory. Let's say theory should say positive. Yeah. I mean you can survey, but assume positive. Therefore, beta 1 is positive 0.6. Okay. And then theory say positive, and then your result also positive. Means good lah. Means consistent with the theory. Okay, like that. Okay, means you can actually proceed with the interpretation. Yeah, if your skill is consistent with the suggested by the theory. Okay, or at least from the other article, like that. Okay. Okay. Any question is?
So convergent validity and discriminant validity, are they opposite to each other?
Yes, correct. You are right. You are right. So conversion validity should be high. Yeah, but discriminant should be low. Okay. But conversion, you should find the variable that are very similar and same concept. They measure the same concept. Right? But discriminant, they are similar but not the same. Okay. Okay. This why we use the term related. Yeah. Okay. Yeah. Ask now. Yeah.
So, sir, we will do this assessment of validity. I think it's not by SPSS, right? It's just like what we is based on our observation, or we have to. I mean, for some validity, we have to really go to correlate with other skill.
No, you should use the SPSS also.
Or
Because
SPSS do that,
you use SPSS to compute the correlation. Yeah, see? Use SPSS to compute the correlation. And then use the past study to compare, like that.
Okay.
Well, of course, the third one is only the past study to compare. But this one, the first, second, you should use the SPSS to do the testing.
So later we will go through this.
I think no. Because this one just based on you find some other variable and then do correlation, correct not? Yeah.
Also, we check by ourselves. Okay.
Yeah, correct. Okay.
Okay, noted.
Okay, so if no question, now we come back okay at 3:30, yeah. 3:30. So 3:30 we should finish this chapter. Okay. So again, I will mark attendance only for 2 times. Yeah, for Saturday. Yeah? Okay, for Saturday, the first and the third. Okay. So see you at 3:30. Okay. Yeah. Thank you.
Yes, sir.
Okay.